Welcome back to my YouTube channel, Massa Tutorials. Please do all to subscribe to this channel. Alright, so now let's do a quick correction here, then we move on to our next subtopic under Math 102, Analytic Geometry and Calculus, which is Collinear Points. Collinear Points. So let's do this quick correction. So now they said find the gradient of the line joining points CP, C on P, then CQ, C on Q. Right. So now on our last video I made a mistake here. So let's correct that fast. So I have x1, y1, then what? x2, y2. So m should be equal to what? y2 minus y1 all on what? x2 minus what? x1. Right. So we know our y2, which is what? C on Q, minus y1, which is what? C on P, all on x2. x2 is CQ minus x1, which is CP. Right. So now the numerator we had m should be equal to, which we had CP minus what? CQ, all on what? PQ. Right. Then we said that this one is the division sign, so divided by CQ minus what? CP, all on what? 1. Right. So we said that m must be equal to CP minus CQ, all on what? PQ. Then times 1 on what? 1 on CQ minus what? CP. This one, if you don't watch it carefully, you will think that they are the same. So that's why I cancelled it. But they are not the same. Kindly watch it very carefully. That's mathematics for you. So you have to open your eyes on certain things, right? You have to open your eyes very, very well. So this one, you can't cancel this with that. Please, let's correct that. You can't cancel this with that because they are not the same. So how can we get that? Then factorize C out here. So you factorize C out, then we get what? P minus what? Q, all on what? PQ. Times 1 on, here we can factorize C out. So C out, we get what? Q minus P. So you can see that this one is P minus Q and this one is what? Q minus P. They are not the same. So if you want to go ahead and cancel out, you can. This C cancels what? C. So I have M, which must be equal to P minus Q all on what? PQ times 1 on what? Q minus what? P. Right. 1 on Q minus P. So now, how do we cancel out? Now, you can let this one be the same thing as that, or you can let this one be the same thing as that by factorizing what? -1 out. Right. So let's see. If I want this expression to be the same thing as that, then I'll factorize what? -1 here. Again, if I want this expression to be the same thing as that expression here, this P minus Q, I want this P minus Q will be equal to Q minus P. Then I have to work on this guy, right? So I have to factorize -1 out here. So I factorize -1 out here. Then here I'll get what? Negative what? P. Then here I'll get what? Plus what? Q. Factorization is the reverse of what? Expansion. So when you multiply through, you have to get back to your expression. So it means that -1 times negative P, you get what? Positive what? P. Then -1 times positive Q, you get what? Negative Q. It's the same thing. We haven't done anything to that. So all on what? PQ times 1 on Q minus P here. Now this one we can arrange it, which is m equals -1. So which is what? Q minus what? P, all on what? PQ times 1 on what? Q minus P. So we can see that Q minus P is the same thing as Q minus P. So now they can cancel out. Right. So I can say that m is equal to what? -1 on what? PQ. So in our last tutorial video, we had what? +1 on PQ. So it's supposed to be -1 on what? PQ. And we said that it is what? Increasing. No, it's supposed to be what? Decreasing. So please correct that for me. Thank you so much. Thank you so much. So that's our correction we want to make here. That's our correction we want to make here. Very, very simple. So this one will get what? A decreasing what? Function, or a downward slope or a downward slope because it has what? A negative what? Gradient, right? The sign here is negative, so we get a negative gradient, so which is what? A decreasing function or a downward slope. So kindly correct that for me so you can watch it very carefully. Okay, so that's that. Or if you want the other way around, you want this expression to be the same thing as that expression here, you can do it as that. So watch here, right? It's very, very simple. You want that expression to be the same thing here. I want this to be the same thing as that. Then I have to work on this guy, right? So that this guy will be the same thing here. So I have m must be equal to p minus q, right? All on pq times 1 on, I have to factorize negative 1 out. So if I factorize negative 1 out, then I'll get what? Negative q, right? Then plus what? P, right? So here negative 1 times negative q, which is what? Positive q. Negative 1 times positive p, which is what? Negative p. So I have m must be equal to p minus q, all on what? Pq, times 1 on what? Negative 1. Then this one you can rearrange it as what? P minus q. So this guy cancels that guy here. So I have what? M must be equal to still negative 1 on pq. Very, very simple. It's the same thing. It's the same thing. If and only if you work it properly, you will all get what? The same answer. Alright, so we are moving on to today's subtopic. So that's what we are moving on to. Today's subtopic. So which is what? Collinear points. Collinear points. So after the gradient, we are moving on to what? Collinear points, because they are interconnected some way, right? And somehow, right? Alright, so collinear points still on Maths 102 Analytic, Geometry and Calculus. Please do subscribe to Massa Tutorials, like and share my YouTube videos. I'll be very, very grateful for that. Alright, so now collinear points. Now let's listen. What is collinear? We know what a point is. Alright, so this one we are talking of what? Two-dimensional plane. That's a 2D plane. Alright, so collinear points. 3 or more points are said to be collinear when they lie on the same straight line. Again, 3 or more points are said to be collinear when they lie on the same straight line. So if we have this line, then we have point A here, point B here, point C here, then point D here. So that's what we are saying here. 3 or more points are said to be collinear when they lie on the same straight line. Alright, let's continue. 2 or more points that lie on the same straight line have the same gradient. So if and only if, or if point A, point B, point C, and point D will lie on this same straight line, then they must get the same gradient. If this one is a positive gradient, this one must be a positive gradient. If and only if you want to lie on this straight line, that's an increasing function. If you want to lie on this straight line, obey the rules and regulation governing what? Collinear points. If you want to lie on it, that's a point. If a point wants to lie on the a straight line, you must get what? The same gradient. So if point A has a gradient of, let's say, 3, point B you have to follow 3, point C you have to follow 3, Point D you have to follow 3. So that we conclude that since they have what? The same gradient, then they are what? Collinear. So that means they lie on the same straight line. As simple as ABCD. Very, very simple. So 2 or more points that lie on the same straight line have the same what? Gradient. So therefore, to show whether or not 2 or more points are collinear. So to show whether or not 2 or more points are collinear, 1. If you want to show that 2 or more points are collinear, then 1. Find the gradient, which is what? M. To find the gradient of the line. Find the gradient of the line. Then 2. If the gradients are equal, conclude that what? They are what? Collinear. If the gradients M are equal, the gradients M are equal, conclude that they are collinear. If not, conclude that they are not collinear. They are not collinear. So I said what? Therefore, to show whether or not 2 or more points are collinear. 1. Find the gradient of the line, right? So you find the gradient of this line joining this point, of this point joining the line. So we have line segments AB. You can find for the gradient of this AB. You find for the gradient of this AC. You can conclude that. Then you find for the gradient of BC. You find for the gradient of AD. You find for the gradient. You just find for the gradient of that point, right? All right. So we have a point, right? A line segment joining what? 2 given points. A line segment joining what? 2 given points. You find for the gradient, then the same thing you find for the gradient, right? Then if they have the same gradient, we conclude that what? They are collinear. And collinear means if the points they have what? If the points have what? The same gradient, then it means that they are collinear. And if you are collinear, you lie on the what? Same straight what? Line. You lie on the same straight line. So 1, find the gradient of the line. 2, if the gradients, which is M, are equal, conclude that what? They are collinear. If not, conclude that they are not what? Collinear. So if they are not the same, we disqualify them as collinear points. Alright, so let's start with example. Show that the 3 points, we are starting with example. Show that, so examples here. Show that the 3 points, 0, 0, 3, 5, and 21, 35 are collinear. So now they say that show that these 3 points are collinear. They are collinear, so show to us why they are what? Collinear. So let's label the point. We start with solution. We can label the point. So we can give this one point A, which is 0, 0. That's the origin. Then we can give this 3, 5 point B. Then we can give this point C. Right. If they are collinear, if the points are collinear, it means what? They must what? Have the same gradient and they lie on the what? On the same what? Straight line. So we have to find for the gradient of what? AB. And if you want to find for the gradient of AB, then y2 minus y1 all on what? X2 minus x1. The difference in the y-axis over the difference in the x-axis. So m of AB, which must be equal to y2. So x1, y1, then we have x2, y2. So y2, which is 5 minus y1, 0. x2 is 3 minus x1, 0. So I have 5 on 3. So, which is a positive gradient, right? Then let's see the gradient of, let's say, BC, right? The gradient of BC. So we find for the gradient of BC. So the gradient of BC, we have the formula there, y2 minus y1, all on what? X2 minus x1. So BC, x2, y2, then we can conclude x1, y1. They are the same thing. So y2 is 5 minus y1, which is 35, all on x2, which is 3 minus x1, which is what? 21. So 5 minus 35, which gives what? Minus 30, all on 3 minus 21, which gives what? 18. Which gives 18. So let's see, minus 30 on 21, minus 30 divided by 18, which is minus 5 on 3, which is minus 5 on 3. Minus 5 on 3. Sorry. Here is negative. Here is supposed to be negative. So 5 minus 35, which is negative 30. 3 minus 21, which is negative 18. So I have negative, so this one cancels. So I'll get 5 on 3, which is positive, right? Then let's see. Let's see again. You can still go ahead and find for the gradient of BC, the gradient of AC. You can still go ahead and find for the gradient of AC. Gradient of AC. So we have x1, y1, x2, what? y2. You can still go ahead and find for the gradient of that. Somebody can prefer to find for the gradient of AB, the gradient of what? BC, then the gradient of, let's say, AC, right? So you can still go ahead and find for the gradient of AC to be what? Sure. Enough sure, right? So let's see. y2 is 35 minus y1, which is what? 0, all on what? x2, which is what? 21 minus x1, which is what? 0. So I have 35 on what? 21, right? So 5 here. We have, sorry. 35 divided by 21, which is 5 on 3. Which is 5 on 3. Which is 5 on 3. So now here, 5 cannot go into 35. 5 can go into 35, but it cannot go into 21 exactly, right? Okay, alright. So now we can use 7. Yeah, 7 can go into 35 5 times, then into 21 3 times. Yeah, sorry. 7 can go into 35 5 times, then it will go into 21 3 times. So now, we are now sure that since AB gave us what? 5 on 3. BC2 gave us what? 5 on 3. Then AC2 is giving us what? 5 on 3. Then we can conclude that the 3 points are indeed what? Collinear. Right? Since the gradient of AB and the gradient of BC and the gradient of AC, they are equal, we can conclude that what? Indeed, the 3 points are what? Collinear. So therefore, we conclude that indeed the 3 points are collinear. The 3 points are what? Collinear. So watch it very carefully. Alright, so let's see. Next example. So that's example 2 for us. Example 2 for us. Example 2. Example 2 says what? The points. Example 2. The points 2, -3, 3, -1, and 4k lie on a straight line. Lie on a straight line. On a straight line. Find k. Now, how best can we solve this? The point 2, -3, 3, -1, and 4k lie on a straight line. Find k. If they lie on a straight line, then they are what? Collinear. Then that means they have to get what? The same what? Gradient, right? So now, let's see. Let's label this. You can say let this one A be what? -3, 2, -3, B, 3, -1, then C, 4 what? K. Right. So how best can we solve this? So we can say gradient of what? AB. What's the gradient of AB? If they lie on the straight line, then that means their gradients are the same. So now gradient of AB, x1, y1, x2 what? y2. So y2 minus y1 all on what? x2 minus what? x1. So y2 is what? -1 minus -1 minus -3 all on x2, which is 3 minus x1, 2. So I have m of AB, which must be equal to -1 plus 3 all on 3 minus 2, which is 2 on what? 1, which is 2, right? So the gradient of AB is what? 2, right? So the gradient of this AB is 2. So now we can find for the gradient of what? BC. Gradient of BC. So I have x2, y2, then we can note here x1, y1. So y2, which is -1 minus y1, which is k, all on x2, which is 3 minus x1, which is what? 4. So I have -1 minus k, all on what? -1, right? -1. So the gradient of BC, is equal to what? -1 minus k, all on what? -1. Now, since they are collinear, then that means their gradients are what? The same. So I can say that the gradient of AB is equal to what? The gradient of what? BC, which is equal to what? 2. Because it is stated in the question that the point 2, -3, 3, -1, and 4k lie on a straight line. So if they lie on the straight line, then that means they are what? Collinear. So I can move on and state that what? The gradient of AB is equal to what? The gradient of BC, which is equal to what? 2. Then I use that to find for the value of what? K. So I can say that 2 must be equal to -1 minus k, all on what? -1. What do? I multiply 2 by what? -1, because I have 2 terms here. So I have -2 equals -1 minus what? K, right? So negative k crosses the equal sign to the left hand side. So I get positive k equals here, -1, then plus what? 2. So I have k being equal to what? 1. Being equal to 1. So I can say that point C is what? 4, 1. So k being equal to 1. So we can verify and see. You can verify the gradient of BC. So when you get the gradient of BC to what? 2, then indeed the value of k is what? 1. So we are off. Very, very simple. Very, very simple. Very, very simple. Very, very simple. So watch it very carefully. All right, let's move on to question 3, example 3. Let's move on to example 3. Example 3. The point 2A, the point 2A the point 2a, negative 2, 2, and 3a, 9, and 3a, 9 are collinear. Are collinear. Are collinear. Full stop. Find the possible values of a. Find the possible values of a. So we are finding for the possible values of a for this point. So it is stated in the question that the points are collinear. If you go to top and down, it is collinear. So how will you solve this question? So if they are collinear, then their gradient must be what? The same. So I can say that let point A be what? 2a, point B be what? Negative 2, 2, then point C 3a, 9, right? So I'll find for the gradient of what? A and B. So gradient of AB, or you can write it as the gradient of what? AB. The gradient of AB, which must be equal to y2 minus y1, all on what? x2 minus x1. So I have x1, y1, x2 what? y2. So y2 is 2 minus y1, which is a, all on x2 negative 2 minus x1, which is 2. So m of what? AB, which is the gradient of AB, must be equal to 2 minus a, all on what? Negative what? 4, right? Now, also, that's the gradient of AB. I can find for the gradient of what? BC, right? Or you can find for the gradient of AC. Anyone, you will move on, right? Any of the points, you can move on. So now, the gradient of BC, which must be equal to y2. I label here x1, y1. So, y2, which is what? 2 minus y1, which is 9, all on x2, which is negative 2 minus x1, which is what? 3a. So I have here to be what? Negative 7. Negative 7, all on negative 2 minus what? 3a. Right? Alright, so very, very simple, very, very simple, very, very simple. So we can move on. We can say that the gradient of BC is equal to what? Minus 7 on what? Negative 2 minus 3a. Since the gradients are the same, and they said what? The points lie on the what? On the same what? Straight line. They are collinear. That means they lie on the same straight line. And if they lie on the same straight line, then that means what? They have the same what? Gradient. So I can conclude that the gradient of AB is equal to what? The gradient of what? BC. So if the gradient of AB is equal to the gradient of BC, then I can equate what? Their gradient together, which is 2 minus A all on what? Negative 4 equals what? Negative 7 on what? Negative 2 minus 3A. Then I'll find for the possible values of what? A. So we do cross multiplication here. So which is 2 minus A multiplying what? Negative 2 minus 3A, which must be equal to negative 4 times negative 7. So now, 2 is multiplying the whole of that, minus A the whole of that. 2 times negative 2, which is what? Negative 4. 2 times negative 3A, which is negative 12A. Negative A times negative 2, which is what? Positive 2A. Negative A times negative 3A, which is positive 3A squared, equals 4, 7, 28, which is positive. Because negative times negative gives what? Positive. Again, 2 times negative 2, which is negative 4. 2 times negative 3, 8, which is what? Oh, sorry. 2 times negative 3a, which is negative 6a. Sorry. Negative 6a. Then negative a times negative 2, which is what? Positive 2a. Negative times negative positive. So I'll get 2a. Then negative a times negative 3a, which is what? Negative times negative positive. Then 3 times 1, which is 3. Then a times a squared. Alright. So I have negative 4. Then minus 6a plus 2a. Negative 6 plus 2. So I'll get negative 4a. Then plus 3a squared, which is equal to what? 28. Right. So now, I have 3a squared minus 4a, then minus 4, then I'll bring this 28 to the left hand side. So minus 28, which is equal to 0. So 3a squared, then minus 4a, right? Then you'll get minus 32, which is equal to what? 0, which is equal to 0. So here we can use the general quadratic formula to solve this. You can use the general quadratic formula to solve, or you can use what? The completing of what? Squares. Completing of the squares method to solve, or you can use factorization. There are more methods in solving for quadratic, right? There are more methods in solving for quadratic. There are more methods in solving for quadratic. So now let's see. How best can we solve this? So I have 3, then minus 4, then minus 32. So how best can we solve this? So if you are using quadratic, you get the general quadratic formula. So you have to compare with the general quadratic equation, which is ax squared plus what? Bx plus what? C, which is equal to 0. We know that a must be equal to what? A must be equal to 3, right? Then b must be equal to what? Minus 4, then c must be equal to what? Minus 32, right? So you can move as that. Or we can change it, because here is a squared, maybe you will not get the understanding. We can change it to what? Ka squared minus what? Let's say G A, right? Then minus, let's see, m equals 0. Aha. So a squared, so we can compare as that. Can compare. It's the same thing. It's the same thing. It's the same thing. So we put that into our general quadratic formula. So which is x equals what? Minus b plus or minus square root of b squared minus 4ac. All on what? 2a. So I have x being equal to, now here is a, so I have to use a. I have to use a because we are finding for the values of what? A. So minus, then b is what? Negative 4 plus or minus square root of b squared, b is negative 4 all squared, minus 4 times a, which is 3, times c, which is negative 32. All on 2 times a, which is 3, right? Very, very simple. Then a, which must be equal to negative negative, which is positive 4, plus or minus square root minus 4 all squared, which is 16, 16, 16, then negative negative, I'll get what? Positive 4 times 3, which is 12, then I have 12 times 32, which gives what? 384, right? All on 2, 3, then I get my 6. So now we proceed, then we can say that a must be equal to what? 4 plus or minus, now 384 plus what? 16, which is what? 400, square root of 400, all on what? 6. And you know that 4 plus or minus square root of 400, which gives what? 20, all on 6, right? Aha. So now we can clean this place so that we get more space and we solve the question very well. So now I have a being equal to 4 plus or minus 20, all on what? 6. So we know that a must be equal to 4 plus 20, all on 6. Then a must be equal to 4 minus 20, all on 6. So I have a being equal to 24, all on what? 6, right? Then a being equal to what? Minus 16, all on what? 6, right? So I have a being equal to 6 here, 1 into 24. I have what? 4. 4, 6, 24, right? 4, 7, 28. So I have 4 here. So here a must be equal to, now 2 here 8 times, right? Then 2 into 6, we get 3. So I have minus 8 on 3, right? So now, therefore, the possible values of a is what? 4 and what? -8 on 3. So that's how best we can solve this question. So watch it very carefully. Alright, we are moving on to the next. We are moving on to our last example, then let's see. Or we can end our tutorials here, then I give you home link. Alright, so you solve 3 examples. So let me give you examples here, then you go and try them. Right, very simple, very simple. They are not difficult at all. I should have given you this question as your home link. Yeah, but we didn't solve much of the questions. We didn't solve many of the questions, so I can't give it to you as home link. So let's home link, right? Home link. They are not difficult. They are not difficult at all. They are not difficult at all. So let's see. We have this question. Question 1. If A -2 1, B 2 3, and C -2 4 are 3 points. Are 3 points. Are 3 points. Determine whether A, B, and C are collinear. 2. Last example then. State whether or not the following points on a line are collinear. So I have point A 1, -2 1 on 3, then point B like 1 0, point C 1 on 2, then 0. Then I point Z 2 3, point Y 4, 1 whole 1 on 2, point K 1 2 on 3, then -2. So this is your home link. Alright, thank you very much for watching this video. It will help you a lot. Take time, sit down and watch it. If you have any problem, kindly drop it at the comment section so that when I get time, I read it for you. I'll respond to you very quick. So please take time, relax, and watch the video. If you like the video, you give me a thumbs up, right? Alright, I appreciate. Kindly subscribe to my YouTube channel so that most of your friends or your friends will watch the video. Alright, thank you for subscribing to Massa Tutorials. Massa Tutorials made easy. Thank you very much. I appreciate it.